Dear learners, welcome to the course Electromagnetic Fields. In electromagnetics, generally we have to deal with two quantities. It may be scalar quantity or vector quantity. These quantities are generally depend upon both time and space. The spatial derivatives performed on scalar quantities will lead to a definition for gradient of a scalar. In this video, I am going to explain gradient of a scalar. Let us consider a scalar function of space coordinates v of x, y, z, which represents, say, temperature distribution in a building, altitude of a mountain's terrain, electric potential. The magnitude of v in general depends upon the position of the point in space, but it may be a constant along certain lines or surfaces. This figure, it shows two surfaces with the magnitudes of v1 plus dv respectively. dv is the small change in the magnitude of v. Observe this figure. The point P1 is on the surface v1. P2 is corresponding point on surface v1 plus dv along the normal vector dn vector. And the point P3 is on the surface v1 plus dv is close to point P2 along another vector dl vector. The condition dl not equal to dn. For the same change dv in v, the space rate of change dv by dl is greatest along dn vector because dn is the shortest distance between two surfaces. Since the magnitude of dv by dl depends on direction of dl, therefore this dv by dl is a directional derivative. Now we define the gradient of a scalar. The gradient of a scalar field v is a vector that represents both the magnitude and the direction of the maximum space rate of increase of v. Mathematically, gradient of scalar is written as del v is equal to gradient of v, that is equal to dv by dn an vector. From the illustration, we can write directional derivative dv by dl is equal to dv dn cos theta. The theta is the angle between the two lines along P2 and P3. These are the two lines joining at point P1. It makes an angle theta. So cos theta can be written as an vector dot an vector. The resultant of dot product of an vector dot an is cos theta. So therefore, dv by dn cos theta can be written as dv by dn an dot an vector. dv by dn an vector is nothing but the gradient of v. So therefore, the directional derivative dv by dl is equal to gradient of v dot an vector. It means that the space rate of increase of v in the aerial direction is equal to the projection of the gradient of v in that direction. dv is equal to del v dot dn. It states that dv is the total differential of v as a result of a change in position from point P2 to point P3 in this case. Gradient is a vector that represents both the magnitude and the direction of maximum space rate of increase of a scalar. So therefore, gradient of a scalar is a vector quantity. As we know that the del operator in Cartesian coordinate system, we can write del is equal to dou by dou x ax vector plus dou by ay vector plus dou by dou z az vector. Cartesian coordinate system, gradient v is dou v by dou x ax vector plus dou v by dou y ay vector plus dou v by dou z az vector. Similarly, for the cylindrical coordinate system, gradient v del v is equal to dou v by dou r ar vector plus 1 by r dou v by dou phi a phi vector plus dou v by dou z az vector. Similarly, in the spherical coordinate system, grade B is equal to dou V by dou R AR vector plus 1 by R dou V by dou theta A theta vector plus 1 by R sin theta dou V by dou phi A phi vector. So, from this, we understand how to write the gradient of a scalar in three different coordinate systems. We should remember these expressions. It will be helpful while solving the problems related to the gradient of a scalar. Properties of a scalar. Properties of a gradient of a scalar. First property is the magnitude of del V equals the maximum rate of change in V per unit distance. Second point is del V points in the direction of the maximum rate of change in V. Third property is, suppose if we consider another function u, which is also a scalar function, then it should satisfy the following identities. Del uv by u is equal to v del u minus u del v by v square. Del u plus v can be written as del v plus del u. Del uv is equal to u del v plus v del u. The gradient at any point V is perpendicular to the constant V surface which passes through the point. The directional derivative of V along unit vector an vector is del V dot an vector, which is projection of del V in the direction of unit vector an vector. These are all the properties of a scale. The gradient of the scalar field V is a vector that represents both the magnitude and direction of the maximum space rate of increase of V. We are going to find the gradient of a scalar with one numerical example. We consider the temperature distribution in an auditorium is given by T is equal to x square plus y square minus z. A mosquito at 1, 1, 2 in the auditorium desires to fly in such a direction that will get warm as soon as possible. In which direction must it fly? The question is, we have to find the direction of the mosquito, where to fly in an auditorium. We have to calculate the gradient at point 1, 1, 2. The scalar function is given, t is equal to x square plus y square minus z. Gradient t is equal to del t. The given t is in a Cartesian coordinate system. So, we recall that gradient b is dou t by dou x ax vector plus dou t by dou y ay vector plus dou t by dou z az vector. Now we find the differentiate t with respect to x, the second term differentiate with respect to y, and the third term differentiate with respect to z. We will get 2x ax vector plus 2y ay vector minus az vector. The question is, we have to find the gradient of t at point 1, 1, 2. So x equal to 1, y is equal to 1, z is equal to 2. Substitute these values in the equation, gradient b, we will get 2ax vector plus 2ay vector minus az vector. So, this the mosquito flying 2ax vector plus 2ay vector minus az vector direction. This is an exercise problem. Find the gradient of a scalar system t is equal to x squared y plus e for z at point 1, 5, minus 2. So, you solve this problem by yourself. Try this and you will get this answer. 10ax vector plus ay vector plus e power minus 2az vector. The given quantity is a scalar quantity. The gradient of a scalar field is a vector field. I hope you could understand gradient of a scalar very well. Thank you.